First, let's start again by writing down what we know. A normal distribution has a mean of 54 and a standard deviation of 6. Now let's begin with A. What is the probability of randomly selecting a score less than 51? So we're looking for a probability of finding a score less than 51. In our rough draft, that looks like that. 54 is the mean, we know that. We know 51 is smaller, so it has to be on this side. And we're looking for everybody that has a score of less than 51. So everybody in the tail right here. Our C formula is x minus the mean over the standard deviation. So 51 minus 54 over 6 just going to give you a negative C-score of 50. And you know it's correct because negative is on everything on this side, so it has to be negative because we know that positive is everything on this side. Because in terms of C-score, right, this would be 0, this is the positive sign, and this is the negative sign. Now we look up the C-score of 0.50, and remember it doesn't matter that it's negative. All we're looking for is a proportion. In this case we're looking for the proportion in the tail. So it is 0.3085. So the probability is 0.3085 that we are randomly selecting a score less than 51. For B, we can see that something is changing because suddenly we have n and we have a sample mean given of 51. We still have from the original problem our population mean, which was 54, and our population standard deviation, which was 6. So now the difference is that we are looking for the location of m in the distribution of sample means. And remember, this is also specified by the C-score and looks almost identical to our previous formula, only that we now use m, the sample mean, instead of x. And down here, instead of the standard deviation, we use the standard error of the means. And now you might go, we don't have the standard error of the mean. So that's again why you go to the next formula and go, okay, what was the formula for the standard error of the mean? That was the standard deviation over the square root of n. And now you go, oh, okay, I have everything. I can solve for that. So we have the standard deviation of 6, because that's given. We know n is given as 4, so that's the square root of 4. So we can solve for the standard error of the mean, and that is going to be -3. So now, since we solved for that, we can plug it back in here because we have everything for this formula now. So we have the mean of the sample as 51. We know the mean of the population is 54, and we just solved for the standard error of the mean with -3. I just don't know why I have a negative, because 6 over 2 is obviously a +3. Do not know where I came up with a negative. So now we have a C-score of -3 over +3. So we have a C-score of -1. And you can double check with the rough draft. Is -1 correct? We had a mean of 54 and we had a sample mean of 51, and we're looking for everybody that had a mean less than 51, so we're looking for everybody over here. So it's definitely on the negative side. So yes, that is correct, right? So this is the C-score of -1. Remember the 54, that would be a C-score of 0, and everything over here would be plus. For here, we're just looking for the proportion. We had the C-score of 1. We're looking for the proportion in the tail again, so that is 0.1587. So we know that this area right here is 0.1587. So the probability of selecting a sample of n equals 4 scores with a mean less than 51 is 1.1587, and that's the answer for B. And B and C are really related because you can see it's almost identical, only the number of scores in the sample increases, and that's really what this question is all about. It's supposed to show you how the standard error decreases because we increase the number of people. So the more people we have in our data set, so the higher the number of people, the more scores we have, the smaller the standard error. So for C, first of all, we have, again, we know that the mean was 54, the standard deviation was 6. For C now we have n equals 36, and m is 51. We're looking for the probability of people who have less, the mean is less, I should write it like this, less than 51, right, instead of x. So our standard error of the mean formula was the standard deviation over the number of n. So standard deviation is 6, but now we have 36 people. 6 over 6, so now we get a standard error of 1. And if you look at the rough draft, it'd still be the same, right? We still have the 54 of the mean. We're looking for 51. And what is the probability of selecting a sample score less than 51? So we're still looking for the same thing we looked for in B. The only thing that changed is the standard error of the mean. So where we had a standard error of 3 for the previous question, when we only had 4n, now we increased it to 36, and our standard error decreased to only 1, right? So now we get the C-score, and we said the formula for that is m minus n over the standard error of the mean. So this is m is 51. Nothing changed here, right? The mean of the population is 54, but now we only have a 1 down here for the standard error of the mean. And -3 over 1 is -3. Now we look it up. C-score of -3. We again looking for the proportion in the tail. C-score is right here. Proportion in the tail is 0.0013. So for the probability of selecting a sample when we have 36 scores with a mean less than 51 is 0.0013. So you just have to remember that the standard error measures the standard distance between a sample mean, right, that's our m, and the population mean, which is our mu. Right, so this right here. This is an n. So I just want you to remember that The standard error tells you how much error to expect if you are using a sample mean to represent the population mean, right? Because you can see that we are working with the population mean here and we are working with the sample mean.